everyone. In this video, we are going to see how we can use our normal distribution in order to help us out answer questions when we are dealing with proportions instead of just means. And in reality, it is a very similar process to what we were doing when we are dealing with means. Let me start off with just a little bit of a refresher, just kind of over here in some white space. So remember when we were doing like our z equation, we set it up where it was saying like z equals our x bar minus the population mean divided by the standard error. And we also wrote that standard error like this, where it was the original standard deviation divided by the square root of the sample size. So if we write down here our standard error, we just say that standard error is equal to the, let me delete that out, the original standard deviation divided by the square root of the sample size, lowercase n. We can rewrite this above as kind of a simpler version of saying just z equals, wrong direction, x bar minus mu divided by the standard error. Okay, so when we look at this, this is where the equations that we were kind of using in order to help us understand and identify like how to answer our question. So when we did things like the norm dot distribution, we would put in like our x bar here, then we'd put in our mu, then we'd put in our standard error because we're dealing with more than one observation at a time, and then we use true at the end here. And so we could just kind of go and click on, it's like, okay, here's our x bar, here's our mean, and here's our standard error. Okay, this also works with proportions. We just have to set it up a little bit differently. Remember that when we are dealing with proportions, we're looking at like the proportion who approve of something, or the proportion who are registered or have more experience, or we're looking at these dichotomizing our categorical data into just successes and failures. And so what we have here is essentially the sample, or let's start off with the population proportion. So our population proportion is equal to pi, but we can rewrite that as the true mean with respect to the proportion. So it's just mu sub p. Like, okay, we can do that. Analogous, we also have a standard error when we're dealing with proportions. Now, granted, how those standard errors are calculated is a little convoluted. Remember, it's going to be the square root of the population proportion times 1 minus that population proportion, and we divide that by the sample size, and that's all inside of our square root symbol. And then instead of using our sample mean, we are going to use p, which is our sample proportion. And so when we write out our z equation now we can say our z equation is equal to p minus, and then I can say, mu sub p divided by, let me put up here real quick just to remind us that this is the standard error with respect to the proportions. We can divide it by the standard error with respect to the proportions. So these equations really are the same. This is just x bar minus mu divided by the standard error. And up here we can even put like mu with respect to x bar. We talked about that, like the sampling mean. And a lot of times you don't see this written because, let me write up here, that mu sub x bar, so that's the mu of the sampling distribution, is in fact equal to the mu of the original distribution. So a lot of times you don't see it written as like x bar minus mu sub x bar. Most of the time, because like these things literally are identical, most of the time you will see that deleted out, and you'll just have this written as x bar minus mu divided by the standard error. And then down here we have p minus mu sub p, or mean with respect to the population, or with respect to the proportions, and the standard error with respect to the portions. A lot of times though you will see this rewritten. Let me just type it out again. But instead of using mu, we will use the population proportion here. And then instead of using the shorthand of the standard error, like if we write out the entire thing, you will see it written like this: the pi times 1 minus pi divided by n, when we type it all the way out. So our calculations using our normal distribution are basically identical to those when we are using these calculations for the sample mean. We just have to kind of rephrase it. Okay, so at this point, I'm going to go ahead and delete these out, and I'm also going to use our bell curve visualization tool using the z distribution proportions. So this is kind of the shorthand for proportions, and it's super handy. However, I also really want you to know how to use the formulas. So we're going to use the formulas as well as we are going along. Okay, and looks like I have a little bit of an error there in our code. There we go. Okay, so let's take a look at this scenario. Let me blow it up a little bit, and let's give ourselves just a little bit more room in Excel. So it says, Jocelyn has decided that she's interested in entering into a cooking competition. She knows that the true proportion of people doing these competitions that have more experience than she does is 36%. At this competition, 198 people have registered to compete. Okay, so the first thing that I want to do is I want to establish what is my true population proportion and what is my sample size. So over here, I'm going to say that my true population proportion is 36% because it told me that that is the true proportion of people who have more experience than she does. And the sample size that we're looking at is 198. And I have this already calculating out our standard error or sigma with respect to the proportions. Let's just go ahead and do this over here as well by hand. So we will just put these as like our key items, and we'll label this one as pi. I'm just going to do it as 0.36 because we're going to do this by hand too. And then we'll do the sample size is equal to 198. And then let's calculate out our standard error with respect to the proportions as well. Or we could write that as standard error is equal to sigma with respect to our proportions. And let's go ahead and do that, equals the square root of pi times 1 minus pi, which is just saying we're going to take the probability of successes multiplied by the probability of failures. You might also see that come up as pi times pi complement, but here it's just easy to do pi times 1 minus pi. And we're going to divide by the sample size. And we can see that, hey, yep, we are able to reproduce the standard error. Different decimal places. This one's just showing to 4, and over here we're showing to 5. Okay. Now we have this one over here. It says, what is the probability that more than 62 participants have more experience than she does? Okay, so we need to write this out in a few things. So the first one is like number with more experience is equal to, and I'm just going to say that that is equal to 62. So the proportion that I'm interested in, remember that's just the count, I need to know the proportion. So the proportion that she's interested in, who have more experience than she has, we'll do 62 divided by our sample size of 198 to find out the proportion of people who have more experience than her. So she's wanting to know what's the probability that more than 31% of these participants at this particular cooking competition have more experience than she does. Okay, so look over here at our z distribution. It's already been drawn out for us. We can see that, hey, the mean is at 36. We set it up here. Our standard error is roughly 3. So we're doing roughly steps of 3 going up and down. So if we look at 31, like 31 is like roughly here. And if we shade the region above, I mean, that's a lot. Like I'm going to be guessing like 80, maybe 90% of, like there's a 90 or, sorry, that there's like a high 80s to maybe the 90% probability that more than 62 of these participants at this particular competition have more experience than she does. So let's write this out in a probability statement. So what are we saying? We're saying, what is the probability that this sample proportion is going to be greater than, and we'll do this 0.313. This is what we are looking for. Now, if we put it over here, we're like, hey, if I want to find, I was given a value, right, that of this 62 people, which is equal to this like 31%. Now, one of the hardest things with dealing with normal distributions and this approximation stuff when we are dealing with categorical data or when we are dealing with these percentages is knowing, is this percentage talking about a quantile or is it talking about like the percentage of people, of participants who have more experience than she does? So up here in this question, notice that it says is, what is the probability? Remember over here, instead of value, let's change this to probability. When it's asking for probability, we are using this stuff where it's giving us this critical point. And it's saying that the critical point for this one is 0.13. But we have to decide, is this from a left cut or a right cut? Notice that it says that, what's the probability that more than 62 participants have more experience than she does? So we want to shade the area to the right. So we're going to start off with this left cut at, we'll just we'll type this in, 0.31313. And the right cut, we're going to go to infinity. And if we click on the values, and it shades in, and then, yeah, check it out. I was pretty close. Right around the high 80s or 90s is what I guessed. Let's see how we're actually doing this here. So it says that, remember, using probabilities, we're going to use our norm.distribution. So I'm going to say equals norm.dist. And then it asks you for x, and it doesn't necessarily means x, it just means what is your critical point. And the critical point that we're interested in when we are using proportions is our sample proportion. So we're going to click on our sample proportion. And then it asks for the mean. And we already know that pi is a mean, right? It is the mean with respect to the proportions. So we're going to grab in that. And then when it asks for the standard deviations, we need to use the standard error. And we always use true for the cumulative part in this class. And we hit enter, and it says 8%. You're like, whoa, what happened? I know that it's supposed to be like 90%. Well, remember that norm.distribution always gives you the area to the left. So check over here at this unshaded region. That's what norm.distribution actually provided you. It provided you with the area to the left. So come in here. If we want the area to the right, all you have to do is in front of norm.dist, we do 1 minus, and now we get the area to the right. And now I'm able to replicate what this dashboard kind of gives us. And if we look at the right answer, answer is 91%. Okay, this competition at this cook-off is really stiff. In fact, it falls into where the top 13%, where the other contestants have more experience than Jocelyn. How many people are more experienced than her? Okay, so here we are. Let's start off with what we know. We know that we are going to, let's write out the probability statement first. So it's the probability that our sample proportion is going to be greater than some like critical point is going to be equal to this 13%. This is how we write if we are looking at getting into the top percentages. So like this top 13%, I'm saying that, hey, my sample proportion has to be greater than some critical point, and I want that to be shaded to be 13. So that's kind of how we write it out and how we can think about this. So what do we know? We want to know the number of people. We'll get there in a second. Let's first start off with figuring out what our sample proportion is going to be. So this like critical proportion, so I'm just going to say this like P underscore crit, or this critical sample proportion, is going to be equal to, well, first of all, let's calculate it. I know that I want my left proportion. Well, let's start off with saying 0.13. And right, I guess we'll go to 1 because we know that we want to go to infinity. And, oh dang, this didn't shade the top 13%. It shaded from the bottom 13% all the way up. You're like, okay, dang it, that's not quite what I want. If we want the top 13% here and you don't want to do math, you can just do equals and 1 minus that 13%. That gives you the top 87. So we're looking at the 87th percentile, which is now that top 13%. Okay, great. So we know that this cutoff point is like actually almost 40% of the contestants at this particular competition have more experience than Jocelyn. Okay, so let's figure out how we're using this with the norm.inverse. So we're going to do norm.inverse. And then it says the probability. It's like, okay, we want to be in this top 13%, which is the probability, this area under the curve. So we're going to click on this 0.13. And then we're going to click on the mean. Again, remember, we have that pi value. Pi is a mean. And we'll then give it the standard error, or the standard deviation with respect to our proportions here. And we're going to close our parentheses and we'll hit enter. And it says that the correct answer is 32%. But wait a second, our dashboard said 39%. Well, what just happened? Well, what happened again is that, hey, we said, remember, norm.inverse always shades from the left to whatever percentage you gave it. So it said, yeah, I'll just shade to 13%, which is why it gave us an answer over here in the like 32% area. We need to flip it over to this other side. Well, remember how we did it up here in the dashboard where we said 1 minus this 13%? Instead, in norm.inverse, we can just do on this probability, do 1 minus, because we want to find greater than, the probability that the sample proportion is greater than some critical point. Okay, so we're going to hit enter and we're going to get 39%. But if we look at the answer over here, the answer is what? 79. Well, if you look at it, it doesn't ask what's the percentage. It says how many people are more experienced than her, and we need to round up. So we'll say number with more experience. And the only thing that we really have to do is take this sample proportion and multiply it by the sample size that we're dealing with. Or I guess I'll click over here. This 198, that's our sample size that we are dealing with. When I multiply those together though, I get a partial, and then it says, remember to round up. Now you can either round up and see that, oh, rounding up is equal to 79, or there's also a really handy Excel function. You can just say equals round up, parentheses, and then go ahead and click on the value that you want to round up. Oops, sorry. We need one more argument where we hit comma, and it says how many digits. If you want to round to a whole number, you type in 0. If you want to round to 1 decimal place, you type in 1. If you want to round to 2 decimal places, you go to 2. But for us, we're going to round to 0 decimal places, which gives us 79. Okay, the last one. It says, Jocelyn actually performs best in competitions where only 32 to 40% are better than her. What is the likelihood that this occurs? Okay, so we're looking at like another probability problem in here. So in here, we're saying, okay, wait, if the proportion is 32% who are better than her, all the way up to 40% who are better than her. Let's look at our values. We shade kind of in this region, and it looks like it's roughly the middle 76%. So let's put this in a probability statement. We'll say that the probability from the sample proportion of being greater than that 32% to being less than 40%. We want to know what that probability is. So what we're going to actually do is we're going to do two norm.dists. The first thing that we're going to do, let me take this to like negative infinity. We go to negative infinity. The first thing that I need to do is I need to find this area, the area to the left of the big value. Then what I'm going to find is the area to the left of the smaller value. And when I subtract those two from each other, I'm going to be left with the area between those 2 points. Okay, so let's go ahead and figure out how to do that. We're going to do equals norm.dist. I need to get the big value in there first. So it's going to be the 0.4, comma, we have a mean of our 36 and our standard error that we calculated out. We want to say true. And then we're going to subtract from it the area of the smaller one, which we get from norm.dist of our 0.32, our smaller one, with the same mean and the same standard error there. And then we're going to do true, and we're going to hit enter. And when we do that, we get that exact same value of that 75.9. So that's how you do that, using both like the dashboard. So use the dashboard to help you out with visualizing things as we're practicing right now. But be sure that you understand how to handle these questions using our base Excel functions. So the ones that we used right now, let me just kind of give you a little heads up. This was norm.dist, and we used norm dot inverse. Those were kind of our critical ones that we used in order to manipulate those. I hope that helps you out in understanding how to use Excel to answer some of these questions. Good luck.